All right, so listen, this is actually like one of the most critical parts of this unit, and I just really need you to kind of key into this. So that's why this slide is orange, because I want you to pay attention to me. Okay, so here's the factor theorem. The factor theorem is like the building block of what works for polynomials. So here it is. If you know that you have a polynomial equal to 0, so this is any polynomial, and you know A is a solution to that equation. So what that means is P of A is 0. So if you put in the number, whatever A is, for X, everywhere that you see it in the polynomial, and you get 0 out, then that's a solution to the equation. What we can say is X minus A is a factor of P of X. And so what we can say here is P of X is some polynomial, and you multiply it, and you can rewrite it as X minus A times some other kind of polynomial. And therefore, this is going to be really useful for us going forward. So I'm not going to really go into a lot about like what we can do right now. We'll talk about that in a second. But yeah, this is really important that you can rewrite it like this. You can also write it the other way, and the reason we can write it the other way is because this is an if and only if statement. If you're remembering from geometry, we can call these biconditionals. Basically, you can go the other way. If you know that you have a factor of P of X, so you know that you already have X minus A times some other polynomial. Then you can rewrite, you can say, okay, well, then I can conclude that X equals A as a solution. And I'll talk about why this makes sense in a second, but depending on the situation, you might need to read the theorem this way, or you might need to read it this way. It's a biconditional, so thankfully you can do both things. Okay, so let's talk about what this actually means for us. So here I have some information about a cubic polynomial, which means it's degree 3. That cubic polynomial has zeros, -2, 2, and 3. A 0 means if A is a 0, that means that P of A is 0, is equal to 0. So that means that if you put in -2, 2, or 3 for X in this polynomial, you will get 0 out. Okay, so what that means is when you put in any number, when you put in these 3 numbers for X here, you get 0 out. So what that means is these things are solutions to the equation P of X equals 0. So X equals -2 is a solution. X equals 2 is a solution. And X equals 3 is a solution. So the solutions that we have are X equals -2, X equals 2, and X equals 3. We can use the factor theorem to say then X minus A is a factor. So if we know X equals -2 is a solution, then we can say X minus -2 is a factor of P of X. Here we can say X minus 2 is a factor. And we can say X minus 3 is a factor of P of X. So what do we have left? Well, we can say, look, now we have these three factors. We have X minus 2, we have X minus 3, and we have X plus 2. And I say X plus 2 because that's what this is here. So I can rewrite this as X plus 2 is a factor, X minus 2, and X minus 3. Factors mean that you can multiply them. Okay, a factor is something that you multiply by to get to a certain thing. So these are factors of p of x, and so we can multiply them out to rewrite what that polynomial looks like. So let's do that. I'm just going to start with this part, and I'm going to use the box method. Okay, these two add to 0, and so I'm left with x squared minus 4 here. Then what I'm going to do is I'm going to take this and multiply it by this, piece by piece. So I'm also going to use the box method here. So x squared minus 4, and I'm going to have x minus 3. Okay, x cubed minus 4x minus 3x squared, and then plus 12. So what are we left with? We're left with x cubed minus 3x squared minus 4x plus 12. And so this is a polynomial. This is a polynomial that has roots at x equals 2, -2, and 3. So we use the factor theorem kind of backwards, from the solutions to the factors. And then when we had the factors, we could multiply them out to get a polynomial that has the answers that we want it to have. This is like a lot of words on this slide, so I get it. But if you know any of these things, there's 4 things on the slide. If you know one of them, then you can conclude all of them. So we talked about how factors of p of x give you zeros, or solutions to the equation p of x equals 0. Zeros mean that p of a gives you 0. What that means is the solutions to p of x equals 0, one of them has to be a, and that's what this says. That's why we call them roots, that's why we call them solutions. Roots and solutions mean the answers to the equation that looks like this. The last part of this is a graphing thing, and it just says, if you know an answer to this equation, then that's where the graph crosses the x-axis. And that makes a lot of sense, because if the output is 0, if the output is 0, then the x value has to be a solution to this equation. Okay, so we're going to use this in a second. Let's take a look at this graph right here. And I notice that I have 3 spots where the graph touches or crosses the x-axis. And what we have is information about this part right here. A is an x-intercept of the graph of the function of p of x. So this is, I guess, our p of x is our polynomial. What can we say about the factors of the f of x? Well, we can say stuff about the x-intercepts. So x-intercepts are x equals -1, x equals 1, x equals 9. And I just wanted to pause for a second, because this spot right here looks like it's bouncing off the graph and not touching the graph. So, and not crossing, excuse me. So what that means is we have a double root at x equals -1. So we have 2 x-intercepts there. It's a double root, multiplicity 2. We can say then, because we have these x-intercepts, we can say that our factors are x minus -1, x minus -1 from these two. And then we have x minus 1, and then x minus 9. Now, how can we check that we're right? We could multiply out all of these pieces together. So I'm going to do these two together first. So I have x plus 1 times x plus 1. That's going to give me x squared plus 2x plus 1. When I multiply out this times this, I'm going to get x squared minus x minus 9x plus 9. Okay, so let's rewrite that really quick. This is the same as x squared minus 10x plus 9. So then I can multiply these two, this and this, using the box method. I'm going to set it up and then I'm going to ask you finish it. This one is like a big 3x3 box, like that. Okay, take a second, finish that up. Okay, here's what I get, x to the 4th. Okay, so combine the like terms, we get x to the 4th minus 8x cubed plus 10, sorry, minus 10 x squared plus 8x plus 9. And check this out, like clockwork. These are the same. And so because we showed that we multiplied out these factors and we got the same polynomial as f of x is at the very beginning, we know that we not only identified the factors correctly, but did the multiplication correctly and interpreted the graph correctly. So we used the x-intercepts right away to write the factors. Then we used the factors to multiply them all out with these steps, and then we ended up with this, and we checked our work by matching it back up with f of x. Okay, here's sort of the summary for the day. If you know that p of x crosses the x-axis at x equals a, this is the most common way we're going to see this. We're going to see a graph of a polynomial crossing the x-axis at certain places. If that's x equals a, then these things are true. Okay. Our goal for next week is to get a bunch of practice solving this equation by rewriting our polynomials as quadratics times linears times linears. We are going to need a new skill that next week when we start doing this, which is going to be, or next lesson when we start doing this, which is going to be polynomial division. So get prepared for that. We'll talk about that next lesson. Have a good day.